In today's lesson, we are going to look at solving equations with fractions. So now these are probably going to be some of the toughest or most complex types of types of equations that we look at, because again, mostly dealing with the fact that we are looking at fractions, and a lot of people don't like fractions. We're going to start off with simple ones though, and then work our way up to some complex ones, and then look at an alternative way to solve a specific type. So if we look at the simple fraction, x over 4 equals 7. What do we do to solve this simple fraction? Right, so again, it is a fraction, even though it may not look like one, but it is only a one-step equation, so that should make it a little bit easier. Well, we think of a fraction as division, right? X over 4 is the same thing as saying x divided by 4. So x divided by 4 equals 7. So going through our steps to solving equations, what do we do to cancel out that divide by 4? Well, in order to cancel out the divide by 4, we multiply by 4. So if I multiply the one side by 4, I also have to multiply the other side. One side will cancel out, the multiplying and the dividing cancel each other out. We're left with x is equal to 7 times 4, which is 28. So this would be our answer. So what did we do? How did we get rid of those fractions? Well, we multiplied by the denominator. So one thing that we can do, you can simplify equations involving one fraction by multiplying both sides by the denominator of the fraction. So that's the key thing that we're going to be looking for. We're going to be looking for the denominator of the fraction, and we're going to be multiplying both sides by that denominator, which will then allow us to cancel out that fraction. So let's look at a couple one fraction equations. So here we have a fraction here. We have 1/3 times 8 plus x, or 6 equals 1/3 times 8 plus x in brackets. So we have this fraction here. We do see our denominator of 3. So in order to cancel this out, I need to multiply both sides by 3. So I'm going to multiply the 6 by 3, or the left side by 3, and the right side by 3. If I multiply the right side by 3, that will cancel out with the division, or the dividing by 3, or that 1/3. And then I'm left with 18 equals 8 plus x. So that bracket is now gone because I've gotten rid of that multiplying, or that fraction that's being multiplied there. So 18 equals 8 plus x. Again, to get rid of the 8 or get the x by itself, I subtract 8 from both sides. One side cancels out. I'm left with 10 is equal to x, which would then be our final answer, or our solution. Looking at another example, same idea. We have a fraction there, 1 over 6 times 2x plus 4 in brackets equals 5. I don't want that fraction. I don't want to have to multiply that fraction through. So to get rid of that fraction, we multiply both sides by the denominator, which in this case is 6. One side will cancel out. I'm then left with 2x plus 4 is equal to 30. Now we have a two-step equation. So again, we start with the separate term, get rid of the 4, subtract it from both sides, cancels out on one side. We get 2x equals 26. To get x by itself, we divide both sides by 2. Again, one side cancels out. X is equal to 13. So again, we cancel or get rid of the fraction, and it turns into something that we're a little bit more comfortable working with. Now, when we have more than one fraction, we have to be a little bit careful. Because when we have more than one fraction, we have to find the lowest common denominator of all the fractions and then multiply both sides of the equation by this value to eliminate the fractions. So it's not just a matter of looking at the denominator of one fraction, we need to take a look at the lowest common denominator of all fractions in our question or in our equation. So if I look at this one, kind of mislabeled it, should be A. 1/3 times 2x minus 5 equals 3/4 times x minus 2. So there's a couple new things in this one. One, we have the two fractions, 1/3 and 3/4. So two different fractions on both sides of the equal sign. We also have a numerator that is not 1. So that is something a little bit different from what we've seen. But we'll worry about that when we get to it. What is the lowest common denominator of our two fractions? Well, we have 3 and 4. So what is a number, or what is the lowest number that both 3 and 4 go into? Well, 3 doesn't go into 4. 3 though, and 4 doesn't go into 3, so we have to find a number other than those. In that case, a good place to start would always be to look at just multiplying those two denominators together, 4 times 3, which is 12. That way you know for sure that both 4 and 3 go into 12. Is there anything smaller? In this case, no. In this case, there's nothing smaller that 4 and 3 both go into. So what we do now is we're going to multiply both sides by 12. Now here's where it gets a little different. So it's not quite the same, because what happens now is we don't cancel anything out. What we can do is we can look at, well, 12 divided by 3, that would cancel out, but we'd be left over with a 4. 12 divided by 4 would cancel out, but we would be left with a multiple of 3, or we would be left with 3. So this changes what we have. This then leaves us with 4 still on top, because 12 divided by 3 is 4. So 4 times 2x minus 5. And on the other side, the 12 and the 4 cancel out. That leaves us with 3, because 12 divided by 4 is 3. And we still have the 3 on top. So essentially we have 3 times x minus 2. So there's a couple things we have to continue to simplify first. So on the left side, we can just distribute this property. 4 times 2x is 8x. 4 times negative 5 is negative 20. On the other side, I'm going to simplify 3 times 3 and get 9 times my bracket. And now I'm going to distribute that 9 through to both sides. I'm going to leave the 8x minus 20. 9 times x is 9x. 9 times negative 2 is negative 18. Now that we've simplified, we can go through and find or break it down a bit further. So we've gone from an equation with fractions to an equation with brackets to a multi-step equation. Let's get rid of the 8x on the one side, get rid of it on the other side. One side will cancel out. Negative 20 equals 1x minus 18. Let's get rid of this 18 by adding 18. Doing the opposite, do the same thing to both sides. We're left then with negative 2 is equal to 1x, or negative 2 is equal to x. Means the same thing. And then we have our answer. So again, the idea is that we're multiplying multiplying the fractions by the lowest common denominator. We've seen now that in some cases it may not cancel everything out. It will cancel out the fraction, but we may be left with a multiplier on top or a numerator still. If we look at the next example, 1 over 5 times x minus, or times 7x minus 3 is equal to 1 over 10. So again, we still have a two fractions, a little bit different, less complicated than the previous one, which is okay, but we're still going to go through the same steps. Let's look for the lowest common denominator. In this case, the lowest common denominator isn't the whatever 5 times 10 is. It's not 50. 5 actually goes into 10, and 10 goes into 10. So our lowest common denominator in this case is 10. So I'm going to multiply both sides by 10. If I multiply the one side, 10 divided by 10, or 10 multiplied by 1/10, the right side just works out to 1. It cancels out to 1. On the left side, 10 cancels out the fraction of 5. However, 10 divided by 5 leaves me with 2. So I still have a multiple of 2 on top in front of that bracket. So I have 2 times 7x minus 3 equals 1. Because of those brackets, I'm going to distribute my property. So 2 times 7x is 14x, minus 2 times 3, which is 6, equals 1. I now have a multi-step equation, or sorry, not a multi-step, a two-step equation. Cancel out the minus 6 with plus 6, do the same thing to both sides. I get 14x equals 7. Cancel out the multiplying by 14 by dividing by 14. X is equal to 7 over 14, or x is equal to 1 over 2. So again, in this case, we saw that when we multiply by the lowest common denominator, we cancel out one side, but not necessarily the other, and we're still left with a multiple that we then have to multiply through. Let's look at C. So C again is similar, it's just in a different form. So this would be the same thing as saying 1 over 3 times k plus 2 is equal to 1 over 5 k minus 4. Same idea, we've just actually multiplied the fraction through, so everything on the left side is divided by 3, everything on the right side is divided by 5. Same idea. We still have our fractions. We want to cancel them out by multiplying by the lowest common denominator. So what is the lowest multiple or the lowest common denominator of 3 and 5? Again, if one doesn't come to you right away, the easiest thing to do is do 3 times 5, which gives us 15, which also happens to be the lowest common denominator. So what we're going to do then is we're going to multiply both sides by 15. And we have to put brackets around the numerators because it's 15 multiplying everything on that side. Now in this case, when we multiply by 15 and then divide by 3, it cancels out the fraction but leaves us with a multiple of 5, or a value of 5 on top still. Same with the other side. 15 cancels out the divide by 5 but leaves us with a multiple of 3 on top. So we then end up with 5 times k plus 2 is equal to 3 times k minus 4. I've put the 3 in front because when we're multiplying, order doesn't matter, so I can just switch it around just to make it or have it look like something that we've seen before. So with our fractions now gone, we have an equation with brackets. So let's use the distributive property to multiply through. 5 times k is 5k, 5 times 2 is 10, 3 times k is 3k, 3 times negative 4 is negative 12. Now I'm down to a multi-step equation. Cancel out the variables on one side, minus 3k, minus 3k. One side cancels out. 2k plus 10 is equal to negative 12. Now we're down to a two-step equation. Get rid of the separate term, or get rid of that plus 10 by subtracting 10. One side cancels out. 2k equals negative 22. We're now down to a two-step equation. Last step, one-step equation. Last step, divide both sides by 2. One side cancels out. We get k equals negative 11, which would be our final answer. So again, same kind of thing that we had to do before, different format or different setup of how our fractions look, but same general idea. We are going to look at an alternative method to solving this one. Is there anything we notice about where we started? I'll write it off to the side. K plus 2 divided by 3 equals k minus 4 divided by 5. And when we got rid of our fractions, we ended up with 5 times k plus 2. It was equal to 3 times k minus 4. Is there anything that we notice in that maybe could cause us to go a quicker way rather than trying to find the lowest common denominator? Maybe you noticed that the denominator on the right side became the multiple on the left side, and the denominator on the left side became the multiple on the right side. So in certain scenarios, specifically when you have one fractional or one rational expression on one side, one fraction or rational expression on the other side, we could cross multiply. And that would save us from having to find a lowest common denominator, and it would get rid of the fractions. So if we look at this alternative method, I can actually cross multiply the numerator on the left side with the denominator on the right side. So we would end up with 5 times k plus 2. Again, in brackets because k plus 2 is in the entire numerator. And on the right side, the 3 would multiply by the k minus 4. Again, all in brackets because it's multiplying the entire numerator. So in these situations, this is what we can do to cancel out the fractions. So this is an easy way if it is set up like this. So it needs to have one fraction on one side, one fraction on the other side. It needs to be set up like this. If we had something else where we had another term, say plus 3, or plus something else, or different fractions or multiple fractions, same thing like that, it wouldn't work. We need to have it set up in this format in order for it to work. Then again, we can go through and do the same kind of steps that we did before, right? We distribute the 5 through. So 5k plus 10 equals 3k minus 12. Again, I'm just going to kind of go through this quickly because we've already done this before. I'm going to do in multiple steps. So those will be gone, those will be gone. 2k equals negative 22. So again, just going through multiple steps because after that, the steps are the same. It's just that initial step of trying to find the lowest common denominator. So let's take a look at one example like that. Again, we have it set up where we have a fraction on one side, a fraction on the other side. There's only one term or one fractional expression, whatever you want to call it, on either side. We're going to cross multiply. It's going to save us from having to find that lowest common denominator. So we end up with 2 times 5 minus 2x, all in brackets, equals 3 times 15x minus 7, all in brackets. Now we still need to go through and use our distributive property, but we should be okay with this because we no longer have that fraction. So 2 times 5 is 10, minus 2x, or 2 times 2x, which is minus 4x, equals 3 times 15x, which is 45x, minus 21. I can go through now, start to simplify. So we're going to get rid of our variables on one side. So I'm going to add 4x, one side will cancel out. We get 10 is equal to 49x minus 21. We're going to add 21 to one side, add 21 to the other side. We get 31 is equal to 49x. One side will cancel out. To get x by itself, we divide by 49. So we get 31 over 49 is equal to x. So again, it may have seemed tricky at first because we had those fractions, but we learned a quick way to get rid of the fractions by cross multiplying. Again, this only works in this specific scenario. Otherwise, it is recommended to use that lowest common denominator and multiplying both sides. You'll still get the same thing in the end. It just kind of saves us that step of trying to find that lowest common denominator. From there, again, we usually end up with an equation with brackets, and we can work our way down and simplify it to maybe a multi-step equation, then a two-step, then a one-step. So it's all about breaking down our equation into something simple or something easier to use and understand. So if you are having trouble with the other types, or once we get rid of the fractions, make sure you look at the previous lessons that focus on the different types of equations, because we will come across them as we solve these complex ones.